Super.
Jesteśmy na żywo?
Mhm.
Okay, then I will switch to English. Again, welcome everyone. It's my pleasure to welcome Przemysław Żelazowski, who will be doing a lecture today. Quick intro before I give the microphone to him. He's an assistant professor at the Center for New Technologies at the University of Warsaw. He's also the founder and managing director of the SatAgro service, which is a service that supports farms in the implementation of precision agriculture and satellite-based crop monitoring. Dr. Żelazowski works on interdisciplinary issues, mainly around the relationship between vegetation, like forest crops, and their environment. And today he will be talking about how satellites are helping us to reduce the carbon footprint of crops in Poland.
Thank you. Do I have the mic?
Yeah, of course, go on.
All right, I'll try to fire up the presentation first. Give me a second. Do you see it?
Yeah.
Cool. Okay, and I have like 20 minutes for this, right?
Around 20-30 minutes, yes.
Okay, great. I am in a pretty unique position to be both a scientist and an active participant in the transformation of the agricultural sector, and I hope that I can give you some practical insights into what's happening. I always start with saying that year 2016 was really a groundbreaking moment because this is when satellites started to be really helpful for the farms because there was finally enough of data around, you know, quickly enough and with good enough resolution to allow, you know, something meaningful to happen for the farms. And obviously, you know, when something meaningful is happening on the farm level, then this extrapolates onto all countries and hopefully the planet. And to give you some examples, here are 3 examples of imagery or of vegetation maps of a certain crop field. And you have a timeline here, starting with 2013. In the first image, this crop field is visualized using Landsat 8. This is the satellite produced by NASA and managed by USGS. It's 30 to 15 meter resolution, and the overpass is every 2 weeks. From the practical point of view, you can imagine that, you know, if the farmer needs a satellite image to do something useful on the ground based on that information, usually they need it pretty fast. And so here with this satellite, we had a chance to give information every 2 weeks. But what happened if there was a bad weather? Then in practice, the farmer would need to wait a month, and month is like forever for the farm. So only from, again, around 2016, when there was some extra satellites launched into space from European Space Agency, notably, and of better resolution. And the overpass went down to around 5 days. This is when we, from the farms, started to finally be able to make some practical use of the satellite information. And then it's only started to get better. From around 2018, we even have you know, multitude of 3 meter resolution images available, and practically every day. So this is crazy how fast the sector has been developing, and as I said, since only 3 years. And again, to show you some more how striking the difference is within just a few years. And in this case, in particular, this slide kind of addresses one of the barriers. I promised that I'll be talking about barriers. So one barrier, obviously, was the temporal resolution, which I have mentioned. There was not enough frequency, and so the farms could not use it. Once there started to be frequency, we started dealing a bit more with the problem of spatial resolution. And here you can see how increased spatial resolution. So here you have 15 meters versus 3 meters. So this increase has opened up all of these smaller crop fields. So this crop field is just over 1 hectare. Okay, it's not a very big crop field, but still, sizable. And you can see that, with lower resolution image, you cannot really see much. But with 3 meter, you can already pick up the trends of what's happening with the crop. So this is an amazing move forward.
I have a question.
So, yeah, here we go.
What we can see on those pictures? What are the colors? What the colors?
Good.
Explain to us.
Yeah, good question. So yeah, this is a very simple vegetation map, and basically, the more green it is, you have a little color scale, and they're in the corner. The more photosynthetically active vegetation is. So it's kind of like the amount of living vegetation per unit area. Okay, so probably in these kind of like violet areas near the edge of the crop field on this high resolution image, there's probably something even more like bare soil, completely damaged vegetation. And then in these green, very green areas, actually here you can even see that maybe there is a bit of forest visible on the image. So this is it. And so nowadays, satellite monitoring, it really starts to be like a part of everyday life of a farm. We tend to think of farms as of these kind of backward thinking entities, but they're actually amazingly forward, a lot of them. And this slide is here to kind of highlight that it's not just satellites, it's all kinds of sensors that are feeding information to the farms nowadays. And then you can even imagine that everything is evolving in a way that there is a kind of like multi-scale interaction with farms, that farms are getting information not only about individual crop fields, but they can also get information about what's happening in the vicinity of the farm. Not only the corn field in my farm, but what's the overall state of corn within 50 kilometers of my farm, and to make this information even better, we can leverage some information that's coming from the farm. So farms, this is another barrier, and this is, one needs to have a lot of understanding for this. People are reluctant to share information, and some of this information, even though it's not personal data, farms may feel reluctant to share information about what they grow, what diseases they have, what yield they achieved. This is pretty sensitive data, but then once they see that they can actually benefit extra from sharing this information, this makes this barrier a little bit less prominent. So the good example is, for example, that if you are willing to share information about your yields, then this can train yield models working on the regional scale better, and then you will get better information in return. And here I have some practical examples. This is like the whole list of areas where satellites can actually help on the farm and can reduce the carbon footprint. But I'll start with fertilization, with fertilizer use, and particularly with nitrogen fertilizer use, because nitrogen fertilizer has a huge represents a huge chunk of the carbon footprint of farms. And not only because the production of nitrogen fertilizer is pretty energy intensive, but also because once this fertilizer is applied, then some of it turns into gas called nitrous oxide, which is a very potent greenhouse gas. We'll be speaking a bit more about this later, but for now, have a look here in this corner. You have a map in the upper left corner. You have a map of vegetation like the one I was showing you before. And with this map, the farm can make a very evidence-based decision to stop applying the same dose of fertilizer everywhere, but actually to start feeding the crop according to its state. And here is an example of an interface which allows to really quickly go from an image through entering a few parameters into dosing instructions, which can be read by the machine. And this has a very significant impact on the environmental footprint or the carbon footprint of the farm, but also obviously when you reduce fertilizer, it also generates savings for the farm. So here in this particular bit, there's almost no barrier, because once the farm sees that actually by doing this they can save a lot of money, this is a huge motivation. So worth mentioning motivations, not just barriers. And this is a bit of a kind of theory behind these so-called precision treatments, okay? So normally what's happening is that across the whole field, the same dose is applied, okay? But as we could see on that image, usually the crop varies in space quite a bit. I mean, it changes from case to case, but there's pretty much always some variability. And what happens is that, as in the upper image, on some parts of the crop field, where the crop is weak, this crop gets too much fertilizer, and on some parts it gets not enough fertilizer. And so what's happening in this first part is that this fertilizer escapes to the environment, and the big chunk of it turns into nitrous oxide, this gas that's very bad from the global warming point of view. And on the other hand, on this other part of the field, this bit of the crop doesn't get enough food. So the farmer loses some of the potential. If they are able to take some of the fertilizer from the weaker part of the crop field and put it on the stronger part of the crop field, then not only they reduce the carbon footprint, but also they increase the yield. So it's again a double win, yeah. And so this is kind of like a theoretical relationship between the amount of these extra emissions from nitrogen fertilizer use and the amount of nitrous oxide that gets emitted from the soil. And you can see that in the middle there was this exponential increase. It's basically what happens is that when there is a big gap between what the crop needs and how much fertilizer it gets, there's a huge increase of these bad emissions with the dose of fertilizer. Okay, then it saturates at some stage, but it never happens. It has to be like a really huge amount of fertilizer. So what we really should aim to is just really feed the crop as much as it needs, which is a bit of a difficult task, but satellites make it so much easier. And just remember that this nitrous oxide is so bad. It's nearly 3,000 times more, has a nearly 300 times greater potential to warm up climate than CO2. Okay, this is something to remember about the impacts of the farms. But one thing is to use imagery to vary the doses. Another thing is to also employ agronomy as a division of knowledge, or an art in itself, to construct a fertilizer management plan. And so again, fertilizer management plan is something that the farms, in theory has been using for a long time. In practice, they always have some trouble implementing it. But nowadays it's possible to not only calculate in a rational way the overall amount of fertilizer needed, but it's also, thanks to satellites, possible to make it in a form of a map, which brings in these really big benefits in terms of both savings and the carbon footprint. And what's nice is that since just a couple of months ago, to have such a plan, I mean, not necessarily in a spatially explicit way, this is a bit of an extra, but to have a plan, it's kind of a requirement in order for the farm to get the subsidy. So until recently, this was not required to get land subsidy from the Common Agricultural Policy. CAP is Common Agricultural Policy. Now we have the new Common Agricultural Policy, and it's mandatory to be careful about calculating how much fertilizer you use. I'll skip this slide. I'll also mention that apart from fertilizer, there are so many other uses of satellites which more or less directly impact the carbon footprint. One of them is precision irrigation. Since we can map the quality or the state of the crop, the amount of water can also vary. And at the moment in Poland, the cost of irrigation is mainly the cost of electricity. Okay, this is a bit sad. The water is getting more expensive for the farms, but at the moment, the electricity is the main thing, and obviously electricity is carbon. So there is this surge linked also to the fact that there have been recurrent droughts in Poland. The surge to dig wells and to implement irrigation. And if the doses of water used for irrigation are varied, this also means that the amount is optimized and the footprint is optimized too. Speaking about barriers, I was showing you the dosing instructions before. Obviously, the big bottleneck is to be able to realize such a map with varying doses in practice. Okay, how to do that? There is a really large amount of machinery nowadays that is able to read in these instructions. So the main challenge is maybe to convert this map into format that is read by such machinery. Even nowadays, it's possible to send such a map through the cloud. So can you imagine that there's actually hundreds of, if not thousands of machines which are connected to the net and which can accept dosing instructions which are being sent from somewhere in the office. There's an increasing amount of machinery producers which switch from the solution where you had to transfer physically the dosing map into the machine to the solution where the machine is connected to the cloud. And it's really, I mean, this is new reality that's happening now. But also for farms that don't have such fancy equipment, it's also possible to use smartphones, tablets with very simple apps to also be able to orient themselves, where they are and what dose they should be applying. And finally, about this, I wanted to highlight that it's not only about reducing the environmental impact. I've mentioned that the big motivation is savings. Savings and profitability. And because the farms are increasingly online, and because this spatially explicit information is increasingly available, this is not yet a common thing, but it's really, it is happening. The wave is surging. By accounting for variability of conditions in space, one can not only reduce, but also, in consequence, improve profitability. So the farms are more competitive, the ones who use these technologies, and this can be even quantified. Here, there is a case where of a crop field where, on one hand, this variability in soil and crop conditions was not accounted for when doing all of the treatments, so fertilizer, crop protection, and so on. And on the other hand, we have the scenario where this was done. I'm sorry, I think this is not showing, but the increase was 17% greater profitability. So a really significant impact. And you can see here there is a plot which shows that when you don't account for the variability in soil, then you get this ridiculous relationship between costs and profit. For very different costs, you get the same profit, whereas taking into account variability in soil and crop conditions, which is enabled by satellites, allows to rationalize the relationship between cost, environmental impact, and profit in each place of the crop field. And with this, I will finish. Thanks a lot.
Thank you very much. I think now we have some time for the questions, either here or if you are watching us on the YouTube stream, then just write there on the chat. And here to our Zoom participants, just raise the hand or just turn on your mic and go on. Yeah, Shimon, go on.
So hi, great presentation, first of all.
Yes.
First you said that you are active participant, so you are a farmer?
Oh no, I'm a founder of this company, SatAgro. You could probably see the logo on some of the interfaces I was showing.
Okay.
Yeah, so I'm. Yeah.
Okay, I have a few questions. So, how do you think farmers could use this knowledge, these apps, and everything that you show?
Well, I was hoping that some of the slides exemplified this. I mean,
I really show how to use it. However, I mean, like the old farmer or just like a 50 or 30 years old farmer how he can use it, or maybe just show him how to use it?
Yeah, so at the moment, a good few percentage of crop area in Poland is being cultivated with the support of some support of satellite data. It's kind of maybe not so obvious, and it starts with more forward thinking and bigger farms, but it's like the impact every year of this satellite technology is increasing. I mean, I have no worry about this, that this will spread even more pretty fast. And I would say that maybe into some extent, the barrier to perceive this is that it's really happening is more in our heads than in those farms. You know, a lot of them, like if you think how the farms need to function, you know, and how they were forced across the last, I don't know, a few decades to be constantly super flexible and forward thinking. They're really adaptable. Even these smaller farms, you know, like they were functioning in communism. Then there was the end of communism. Everything was changing. Then, you know, we were accessing the EU. We had, you know, all kinds of new rules they had to adapt to. And now we have the new EU Common Agricultural Policy, which is also like changing the rules so much. And they constantly need to adapt to new conditions. And this is not a new thing. It's true that it's so much easier to work with younger people who use digital technologies. But then again, this is a big percentage of the farms that are, you know, checking weather and other things all the time on their phone, and it's not very difficult for them to switch into some kind of app that's feeding them satellite data.
Okay, thank you. Can I have another question? So how is it possible to predict harvest from the data from satellites? Do you use like last year data, or you just need this year data from satellite?
Mm-hmm. Okay, so in my experience, since it's possible to monitor the development of crop from the beginning till the end, this whole like quantification of the whole gross primary production that's visible from space, for a lot of crops, this is a very good indicator of the yield. I mean, there are some crops, I mean, there are some kind of critical moments, especially for some crops. Like the most strong example would be from not the crops that I'm dealing with, not the field crops. So for example, in orchards, right? When you have frost coming at the time of blooming, and the frost destroys majority of flowers, then, you know, the apple trees may look beautiful from space, but they've lost flowers at the critical moment. They will have no apples. But excluding these critical events, from my experience, just global mapping of, mapping the gross production from the beginning till the end is a pretty good predictor of yield.
Okay, thank you.
Cheers.
Faustina? Yeah.
Okay. So I wanted to ask about this app, I guess, SatAgro.
Mm-hmm.
I saw that it was a demo version of something like this, and I wonder if it's possible for us to look at it, or is it like demo version that we can research and somewhat see for ourselves how we can use it?
Right. Well, the demo is pretty rich in information, especially since there is a proper agronomer working on it since about a year. So it's a very good starting point. But then, well, like it would only make sense to start your own account, I would say, if you have some particular patch of land that you wanted to monitor and understand some more. I guess in that case, you can get in touch and start negotiating.
I mostly wanted it for the for the research in our project, but
yeah. There's also a help section, you know, like have a look at the demo and the help section, and you can always get in touch if you need more information.
Okay, thank you.
Okay, so I have a question also regarding our project. What sort of innovations can be done here in this field of, carbon emission through crop fields? Do you think about any other technologies or maybe more data that can be used in order to lower the emission? Because you mentioned fertilizer, irrigation, but what else could be done there? Maybe you also I don't know if you experiment, but possibly do you also examine the bare soil before the crop is, for example, planted? Or do you maybe examine what types of crops are suitable for the given area? Because I can imagine that farmers, because of the subsidies, they choose the types of crops that they are profitable, right? But not always the land or the given area is the best for this sort of crops. Okay, so I gave you at least 4 questions in this one, but anyways, that's really interesting for me.
Okay, well, the decision what to grow is a kind of trade-off, you know, between like different factors, and the most important factor is what the soil quality. Yeah. And the farmers understand pretty well the relationship between the soil properties and what can be grown there. It's a relatively standard knowledge, and they know it better than me. So don't ask me too much about that, please. Sure. Then obviously there are incentives from these EU schemes, but then, you know, they would still kind of fit within the limits of soil, I would say. And you also have to remember that the crops are being rotated all the time, right? So on every patch of land you have on average, you know, 4 different types of crop being, you know, in rotation all the time. About different ways to reduce the footprint. The slide I didn't really show because I thought I'm running out of time. Was about detecting bare soil and trying to minimize the amount of bare soil, because this is basically keeping the soil bare and even worse, overturning it creates emissions. So there are all these incentives nowadays. It's part of this movement called regenerative agriculture. To try to not turn the soil too much and to try to use so-called cover crops. And it's like a really big, 2 big areas, and there's a lot of research there, and a lot of things to be discovered. Because we know that satellites are super helpful to optimize fertilization. This is what we focus on, and the relationship between even this relationship between the doses of fertilizer and the amount of emissions that I was mentioning. Even this is not solid science, you know. There are some, like every year there's like new meta-analysis and some deeper look at this. We still need a lot of experiments to have like a better grasp on this. But in my view, because, you know, majority of farms are really pretty intensive farms, they use a lot of fertilizer. I would say that tackling the fertilizer problem is like really the key. And sometimes I would even say that it's overlooked a bit. because there's been so much emphasis on regenerative biological farming, but still the majority of farms is intensive, right? And this is where some low-hanging fruits are.
Okay, and do you think that nitrous oxide that you mentioned, that is like a super difficult greenhouse gas, but is there a possibility to offset this sort of gas with crops as well? Do they use it, or this is just a byproduct that it's not used by crops anymore?
No, it's just like when you have too much fertilizer lying in the soil for a bit too long, then bacteria turns it into nitrous oxide.
Okay,
it's the bacteria that's kind of eating it. It has like not much to do with crops.
Sure, but but do you know whether nitrous oxide could be a next resource for something like?
Right.
Can it be used?
Well, that's a very good question, but it will be like, this is the problem with the farms, because they are so-called non-source pollution, right? So that's why like the Baltic is so unswimmable sometimes, mainly because of the farms, because it's easy to tackle the sewage from cities and from factories, but with farms, because it's such a large area and small amounts percolating slowly, it's very difficult to tackle, and it's not really possible to harvest this gas once it's there. There are some solutions, some newer generation fertilizers, for example, have some extra compounds which slow down the breakdown of fertilizer. So that's one thing, but once it's broken down, there's not much you can do about it, unless you figure something out. Maybe there's some other chemical compound that can be spread together with the fertilizer that will help.
Yeah, that could be very interesting. And I also asked you about the possible innovations in this field. Do you think that there is a possibility, like the next steps or different technologies incorporated or different ways of using this data? We're just considering it in our project to actually move forward some of already. Yeah.
Well, this is very interdisciplinary area, and there's so many subjects. Like in the SatAgro company, there are 15 people employed, and the work, the kind of like R&D work is scheduled for the next 3 years, and everybody is super busy and like not having enough time for the clients sometimes. Yeah, so it's really like, it's a separate conversation which we can have. There's a lot to figure out. Like
maybe we can help you as a group,
Yeah, sure. Of course. This is like we've worked with students since the beginning, and since the beginning, students were becoming our employees. This is how we function. So just get in touch.
Sure. Then we'll discuss it internally about the things that we learned today, and maybe we can actually, I think we will be in touch actually, what we can do, for example, together, or what sort of innovation, even speculations for the next 10 years we could work together during this project.
Cool.
Thanks a lot.
Thank you. Are there any more questions?
We have a question from, sorry, go on. There's one more from YouTube, but please go on.
Cool.
Yeah. I have the last question probably from here. So I wanted to ask you about the after crops. Can you predict what to sow? Like, because I think there's a gap between you harvest and sow like the proper wheat or etc. And this is after crops or something like that. And can you predict from satellite data what should you like sow as the after crops?
You mean the after crop, meaning like crop following after the current crop?
I mean the crop between, this is called poplon, I think in Polish. This is the type of crop what you sow after you harvest. So the field, for example, doesn't stay empty for the next spring. For example, if you sow spring wheat or something like that.
Yeah. So it's either poplon or międzyplon.
Yeah,
so
yeah.
it's after crop or intercrop. Intercrop is the one that's filling in the gap. So for example, when you have, for example, wheat or winter wheat, which is harvested in August, and then the next crop plant is, let's say, corn, which is only planted like between late April and May. Then you have this gap of a few months, and in the worst case, the soil can be left bare for a big chunk of that time. So this is when you would use intercrop. Sometimes they called, there's also a special name, catch crop, I think, which is these legumes which capture nitrogen from the atmosphere. And they don't really use nitrogen from the soil that much. They are able to, thanks to some bacteria, to generate nitrogen to use nitrogen for their growth, the atmospheric one. So then, instead of harvesting them, you actually mix them in the soil, and this is so-called green manure. So it's a bit of a side subject, but this is something that, like, an important factor to consider. And I'm not sure if what you meant by predicting, Kuba. Usually you have these pretty standard crop rotation schemes. So
it doesn't look, it cannot work like, because you saw to us that with fertilizer you can like put them in special places on your field. And I was wondering if it can like work the same with the your green manure or something like that.
Mm-hmm. Yeah, it's a good question. But I think the answer for now is no. But there's no such practice. But it doesn't mean that maybe you can figure something out. Maybe actually there is like a special case where you can map some area and say, no, you have to put this particular intercrop here for some time because it's going to do something special with the soil, and which we have detected before that it's required. I have no such case in my mind, but it doesn't mean that such case doesn't exist.
Okay, thank you very much.
Cheers.
Maybe let's answer the question from the YouTube, and then Natalia.
Unfortunately, the question from the YouTube was retracted. I would really kindly ask the person to just send it again. It's no worries, we will have time to answer it. But in the meantime, Natalia could go with her question.
Yeah, thank you. So I'm not sure if you said that, and I'm not sure as well if there's some kind of index for that. But is it possible to make an assumption on what kind of pesticides the farmer use on the crops based on the satellite data? And maybe that's the follow-up question. Is it the way that you look for clients?
No, it's not possible to detect how agrochemicals are used in the field. It's more likely that this technology is useful the other way around, that you look at the properties of soil and crop and do some recommendations on how to use agrochemicals of different kinds. So it's more that direction. But I want to mention that there's like this whole new area new kind of wave of technology and science that's kind of happening now, and maybe it's worth mentioning that nowadays we have these satellites which are called multispectral. So they have like a few spectral bands up to something just above 10, maybe 20, and the bands are fairly wide, usually, you know, a couple of tens nanometers. But there is now this search. I think in a couple of years we're going to have quite a bit of so-called hyperspectral satellites, and this is a bit, you can look at it as kind of like spectroscopes that are being put in space, and with this, you know, spectroscopy happening in satellite monitoring, this opens up a lot of new opportunities. And I don't know, maybe even some compounds when they occur in you know, high enough content, then maybe they could be mapped. I mean, there are certainly papers in, like, good papers published where these hyperspectral satellites are mapping different chemical compounds in vegetation, some dominating compounds. So probably, you know, we are just before the next revolution.
Okay, thank you.
Thank you.
I see that the YouTube question didn't come back.
Didn't? Okay.
Unfortunately, no.
All right.
Szymon.
So maybe last question. So we focus on using too much fertilizer, but is it possible to check if or predict that farmers overwater their plants?
Yeah, good question. I don't know. Maybe that's the subject you should be cracking. I suspect yes, by combining different. This is a kind of like yeah. Sorry, I think this is a good question. I don't know the answer to it. I think if I think some more, I could recommend some kind of different angles and data sources to combine to have an answer to that. But in practice, this is not really done, from what I know. But yeah, no, good question.
Yeah, thank you.
I think if there's nothing else, I don't see any raised hands, so perhaps we can slowly wrap up. We'll just check the YouTube, but no, there's nothing more. So I just wanted to say thank you for the inspiring talk and staying so long with us and answering all the questions. Is there any...
50 minutes. That's not very long.
Still. I hope it was very inspiring for the participants and also for our YouTube guests as well. Again, thank you very much.
Right. Thanks a lot, everybody, and good luck with your work.